Okay, finally, we invite Mr. Gordon Meadow to speak. Gordon co-chairs the Maritime Autonomous Surface Ships SIG, the MASS SIG, and Gordon will present on the outcomes of a series of roundtable events recently held by the SIG on the impacts of technology progression to operations.
Good afternoon, ladies and gentlemen. The IMarEST Marine Autonomous Surface Ship Special Interest Group, MASS SIG, is undertaking to evaluate the functional changes and the future skills requirements during the shipping industry's voyage in automation, has the following objectives. To inform how future seafaring functions, responsibilities, roles will migrate, to identify the ongoing expertise requirements in the operation of commercial vessels enhanced by remote and autonomous technology, and to clarify succession planning requirements, workforce skills breaches, and future training technologies. I am the chair of the MASS SIG, and I'm co-chaired by and I'm supported by a couple of colleagues as co-chairs. Seafaring in 2050 will be different. The worker demographic will be more diverse, as well as the working environment. Decision support technology will combine with established roles and analytical tools to deliver objective, repeatable actions, with the human working in, on, and off the loop. Decision support capabilities will be introduced to accelerate and augment human decision making in real time. By 2050, we could see more than 50% of operational functions mimicked by machines. This doesn't mean less people. Robots are not the significant threat to employment opportunities. The threat to employment opportunities comes about by failing to adapt. Through retaining, retraining, and assimilation of new skills to perform new functions through continuing professional development. The future, therefore, will see new ways of working, a more highly trained workforce with new skills and with different roles and new career routes to support different operational requirements. However, these changes to seafaring skills demographic require preparation. So we need to ask questions like, what are the existing skill sets across the current workforce? And what are the skill sets required of a future workforce to identify and benchmark against the gaps? What might these skills requirements, or how might these skills requirements change over time? And how can these skill sets be delivered? Why do we need to prepare? Because Eric Taylor, the ex-CEO of Google X, came up with the knowing and doing gap, and basically what he said, based on the advance of technology and humans' response to that advance, we need, for any major technology paradigm shift, we need to train the workforce 20 years previously. So the message from the MASS SIG, through simple really, hype in and around remote autonomous ships, is you need to separate hype from the real drivers technology's commercial promise. But what hype does, it helps us to prepare. Automation is a tool and not the goal. We must use automation as a tool in achieving the goal, not simply the goal itself. It's simply a medium. And then manage change through education by forward planning. Long-term thinking is imperative given the rapidity and complexity of change today, to prepare the youth of today to meet the challenges of tomorrow. In early 2018, and taking place in Singapore, we held the first of a series of roundtable events termed Remote and Autonomous Shipping, putting the human back in the headlines. And we looked at two areas. In the first report, it was around a SWOT analysis, where we examined the results of our survey, an IMarEST survey, to identify the strengths, weaknesses, opportunities and threats for remote and autonomous shipping on a sector-by-sector basis. And the second area we looked at was the operator's response, workforce succession planning, to establish recommendations for workforce skills and training. And that was based on a pragmatic approach to talk to real-world ship operators, real-world ship owners, managers, and so on. The Manila Roundtable is the second in this series. And the principal aim is to highlight the nature of future human-machine integration and the performance of the onboard functions required to operate a generic commercial vessel safely and efficiently. The Roundtable of ship owners, operators, and crewing managers identified some of the changes likely to occur to onboard roles at a point roughly 10 years from now in 2030, and a second point around 2050. The Roundtable further sought to understand the ways in which advances in automation technology should be assimilated into the shipping industry. The findings of the report, which will be published next month, will help to determine the rationale and the extent in which to augment human capability with machine digital functionality. or functional assistance on the basis of real-world needs and practicality. So the report represents the views, not Gordon's views. The report represents the views of ship owners, ship operators, ship managers, and regulators. According to the World Economic Forum report on the future of jobs published in 2018, there are 3 key managerial challenges that lie ahead. The first is shifting the training of workers from prediction-related to judgment-related skills. And the second is assessing the rate and direction of the adoption of AI technologies in order to properly time the shifting of workforce training, not too early and not too late. And the third is in developing management processes that build the most effective teams of judgment-focused humans and prediction-focused artificial intelligence agents. We see an awful lot about the human versus the robot. Well, the future isn't necessarily about the human being the parent. It's about us working to understand how we best, isn't necessarily versus the robot, is how we work with the robot. The adoption of the artificial intelligence agent comes at a time where humans increasingly require stronger analytical and organizational skills, as well as the ability to listen, emphasize, explain, advise, influence, and negotiate, all whilst navigating complex project systems. AI assistance will help to spot red flags hidden in a massive torrent of fast-flowing data flows. Analysis of high-velocity data will still, while it's still in motion before it's stored, to help the human take immediate action on what's relevant and ignore what isn't. At present, the relationship between the machine and human for the shipping industry has been situated in industrial automation. However, the advent of AI through cognitive computing means that the adoption of the artificial intelligence agent will provide decision support technology, accelerating and augmenting human decision-making in real time. Where previously automation has been taken mainly in replacement of the brawn, the future of automation for the shipping industry is in replacing of the brain. A further drive toward the justification for remote and more autonomous operation of shipping comes from the recommendations made in Industry 4.0. However, whilst these principles provide a solid theoretical foundation in justifying the removal of dull, dirty, and dangerous tasks to which humans are not suited, there is also a practical point of view for the shipping industry. As was established from the Singapore Roundtable that we ran in early 2018, from a business case, the next steps in the shipping industry in the voyage towards the more remote and autonomous ship and the use of AI technology is in identifying the functions that we as humans would be better handing to the machine to meet business goals and to make operations more efficient and with less risk. Establishing the complexity and the performance of onboard functions in this way will benefit further adoption of AI technology and will help progress. Where are we now? Is irrelevant? Well, it is irrelevant in terms of the methods to be used in building the technology. In each case, the technology requires to be taught. So at this stage, it's the human's tacit knowledge in the first instance which should be consulted and understood before the technology can be fully developed. This iterative process will provide the flexibility and agility to quickly assess progress to determine whether an alternative approach is warranted or if enough is enough. So the Manila Roundtable brought together the expertise from the shipping industry to add the knowledge to the body of knowledge in understanding operations from a real-world perspective, mapping the complexity and the performance of the onboard functions required to operate a ship. So the goal was to capture, track and evaluate future changes to seafaring rules, measuring the impact of specific functional requirements currently performed by personnel during the ship industry's voyage towards automation at 2030 and 2050. So predicting the rate and direction of change to properly time the shifting of workforce training to protect against skills breaches in seafarer workforce will shed light on future skills gaps. So where do we start? So we started out by trying to map all of the macro level functions that are performed at sea across engine and deck. So we started with thinking about capability requirements, operational requirements, ship voyage status, ship-to-shore assistance, and all of the functions that are performed by onboard crew, and have a look at the practicality of that actually being whether the human needs to be on board or how clever does the machine need to be able to perform that actual task, and talk to ship owners, operators and managers and people who know what they're talking about to see what the answers might be. we eventually came down to two rough headings: capability requirements and ship voyage status, and this is what we presented to the ship owners and operators on the panel. And then we had to have a means of analysing it, so we came up with a tool called HAMAS, and HAMAS is Human and Machine Interface Status. So this is the extent to which humans are high reliance, so high reliance on human skills, so little automation and lots of human adjustment, through to the other end to full functional performance where decisions are made through machine learning capability and no need for human participation. So we tried to create some sort of hierarchy at which we could use to be able to analyse and see, what level of human performance is required to do this. Should they stay on board, or should they come ashore, or can they from a business case point of view? So we then ended up with this, and this is what we took to the panel. So with these two rough headings, capability requirement and ship voyage status, then we asked them individual questions based on, okay, if you want to perform this, what level of human reliance do you think there will be in the year 2030 and the year 2050? And we coded it, so we gave them this key, and we used 2030, and we also used 2050. I know I'm skipping through the slides, but the report will come out, so you'll be able to read it in more detail, but this is just a sort of early dissemination. So this is what the panel reviewed, and then we came up with this kind of heat map, that sort of idea as to where we thought that humans would necessarily be in the future on the level of human reliance. So the testing, we tried to use a novel idea of having two ships coming out of the yard. The Horizon was coming out of the yard in 2030, and the two new builds and the Succession was coming out of the yard in 2050. And these were generic cargo vessels sailing on international voyages. And we asked the panel and said, with a focus on the years 2030, which functions must remain in situ, and which functions can be performed remotely, and which functions will likely reach end of life. And then we, based on real-world practicality, what your experience is of really operating a ship is what is the likely level of human reliance over machine assistance based on actually how you perform tasks at sea. So then we used Slido, and we gave them this tool here called HAMAS. And HAMAS, I know you can't read it, but it's at the top. We've coded it so that kind of the blue relates to that function being performed at sea, and then the red line is the lower reliance on humans and necessary human skills and supported by the machine, but they're still on board. And then the green is kind of a shore-based function. So some of those functions could necessarily be moved to shore. So I hope that makes sense. Remember this point because you'll need it in just a moment. Okay, so and then we asked the panel to vote, and then we collated those details. So first of all, the response to the capability requirements. Now, what I'd like you to do, please, is you can use your own analytical skills. I hope you can see the percentages. Now, we'll present this in a more effective way when we come to present the report. But what this shows on the left-hand side are these responses. So this is propulsion, and this is what the panel thought the potential for lowering levels of human reliance and where they would be in 2030 necessarily, potentially, and where they would be in 2050. So the green indicates that the panel thought maybe by 2050 the controlled propulsion would be on shore. Now that's not every ship, and this isn't my opinion. I'm not an engineer. This is the opinion of the panel, and this is it's very broad brush as well. There needs to be more research into this, however, but it does capture some data. Now, I've drawn out, if you do your own analysis, I've drawn out some of the comments that were made by the panel as we moved along. So in terms of propulsion, so due to today's theoretical opportunities, there is a requirement for propulsion systems to be reconsidered from an operational as well as a regulatory perspective. The panel also felt that greater focus needs to be on automation rather than unmanned systems. Remote and autonomous doesn't necessarily mean unmanned in all cases. So if we were to progress more quickly, a better focus on automation. By 2050, in some cases, propulsion could be a task that overseen from the shore, as in the case of the aviation industry. As technology develops, the cost will reduce in terms of implementing expensive equipment, and that's a huge barrier. So it reduces the amount of human involvement in the process of ship propulsion. So the next one we moved on was ship supporting systems. This kind of relates to the engine room and those supporting systems that the engineers look after. You can see for yourself, you can do some level of analysis. So even greater automation on board vessels for supporting ship systems was seen as logical by the panel. there'll be a merger, they felt, between roles and responsibilities, deck and engine functions as technology on board ships becomes more integrated in ship systems. There was a concern over ship design. Would an automated system, which has been overridden by a human, be more dangerous than having it fully automated? So the crucial focus for any designers is that the design implementation and the human-machine integration is absolutely crucial, because that's where it will break down. Performance and efficiency. The panel felt the reduction in human reliance up to 2050 for performance. There will be a complete reduction in human reliance for performance, efficiency and monitoring by 2050. And that the machines can and will be able to monitor themselves. And that's where the technology comes in helping the operator to identify red flags and to manage a huge stream of data and to step in as the operator to see this. Up to 2030, so safe evacuation of personnel, and this is clearly this is a very contentious issue. Up to 2030, there will be very little shift in taking the human out of the loop when it comes to safe evacuation of personnel, and rightly so. The panel felt that even with other automated technological solutions, the human must have the oversight and make decisions parallel with technology. Longer term, by 2050, adapting and incorporating technology as it develops that will save lives is a good thing, and we should progress. Elevating technology in the decision-making process will require social acceptance and a roadmap for integration within the current personnel. So if we were to change anything in relation to safe evacuation of personnel, we fundamentally have to change SOLAS. Administration. This is a burden not solely reserved for the seafaring occupation. This is a common theme. The panel felt that as we move to the more integrated shipping industry, the Internet of Things will have greater influence on administration more generally. And the significance of, by 2030, 2050, the significant administration should fall on aid where that role is passed more to the machine. And then the last one in this series was physical maintenance. Maintenance from an owner's perspective is based on the business model. If the ship owner is going to hang on to the ship for a short period of time, then potentially they won't maintain it as effectively as they would necessarily they're investing in a piece of equipment that they're keeping more long term. And it's simply about the business case. Ship design, the panel felt, will change to a more modular approach longer term, and that would see a significant reduction in ongoing physical maintenance. And the longer goal for ship owners, operators, and managers is that the panel eventually, one day, will be maintenance free. Maintenance free is quite an aspiration, let's face it, but that's the goal. And based on past trends, it's likely that design changes will facilitate even less visits to the shipyard. Okay, so then we move on to ship voyage status and the kind of the subtasks or functions that are performed through it. So this is cold ship to port standby. According to the panel, this is now a fairly routine exercise for the second or third engineer, which isn't a significant task to carry out. However, they did point out that there are certain types of engine rooms require more input because of their complexities. Whilst there are many fundamental differences between the aviation industry and shipping, which have to be recognised, aircraft do not have any engineers on board, and something the industry should work towards. By 2050, many elements of preparing the engine for port standby could be handled remotely, but regulation is the barrier to progressing this. And we're coming towards the end. Port standby and commencement of manoeuvring. Chief engineer, upon commencement of manoeuvring, in many cases they suggested was on the bridge monitoring equipment semi-remotely anyway. So shipping companies, they recommended, will need to assess the cost benefits of whether having someone on board is better than having a human in the loop on shore. Manoeuvring, so commencement, manoeuvring from commencement of passage at sea, so pilotage. Manoeuvring to commencement of passage at sea will still need crew on board until 2030 at very least. The results presented reflect the view that the engineer could eventually, in some cases by 2050, still be on shore or relocated to the shore. The need for engineers is crucial, and the panel sought to emphasise that, but in the future they will not necessarily have to remain on board. 2050, there will be a split. The panel felt the split between deck and engine functions will start to disappear. In the future, workers will perform functions using a more integrated set of skill sets. So that's what they felt. And they felt that this should be communicated to the industry. So full away, longer term, the panel felt that it was possible to operate a vessel without engineers on board, a full away. But regulations are the barrier to this. But here's the rub, is it's an emergency response and repair. The operating is a hostile environment, and it's the most significant factor. In a modern car, if a car senses a problem, it will either stop or go into recovery mode and slow down. A system can't necessarily fix itself or clean up any spills, so that's where design comes in. Failure through poor system design is the greatest risk to automation, according to the panel, and staff still need to be well trained and need to know what to do in an emergency. Technology brings ever-increasing risk, and they want to point out reliance on cybersecurity threats. And that is me. Thank you very much.
Gordon, thank you very much indeed. Before we go on to direct questions, I'm going to answer one myself. We had one in there about, how do the Human Element Working Group and the MASSIG work together? Do they do joint work? And to answer that, yes, they do. This is one of the drives of the TLB, is to really get our SIGs collaborating and working together properly. So actually, it's not just the Human Element Working Group and the MASSIG, but also the Small Ships Group and what we call MEX, the Marine Electrical Control System. So we have and members of the executive pulling all this together. So we do actually put a lot of work into making sure we don't just operate SIGs in pure isolation. They really do come together and work together well, and that's been a drive in many different areas, such as climate change, and also we're looking at polar issues coming up soon. So just to reinforce, they may feel like contentious issues sometimes, these two subjects, and on the face value they can be, but actually the IMarEST works really hard to try and pull this all together so we understand each other together and what the two agendas are, or the multiple agendas are, so that we get the right results and the right outputs. But I'll hand over to Bev for some other questions.
As you can imagine, we've had quite a few questions on this topic.
I'll brace myself.
The first one is, in which sector do you believe autonomous shipping will first manifest itself as being the leading technology, e.g. coastal ferries, tugs, small container ships, etc.?
So in the report, if you read the first report, that kind of looks towards that question. It's already happening. You've got small craft who are running autonomous operation. In larger commercial vessels, it's hard to say. We looked at, when I was formerly an associate professor at Solent University, and one of the areas that we looked at was short sea shipping. We ran a joint research project along with Rolls-Royce, where we built a virtual engine room to see if we could relocate the chief engineer from the ship to the shore. And that was a vessel running from Southampton. That was a case study from Southampton to Southampton to Cowes. And short sea vessels are being looked at and built in place simply because the technology is easier to look at, easier to maintain, and so probably shorter distance vehicles. Sorry, my head's going. Someone asked me yesterday what my phone number was, and I genuinely couldn't remember. I feel like I'm underwater. So in answer to your question, probably clearly short sea routes, the lowest hanging fruit.
And in scenarios like collision avoidance, where do you draw the line between the human taking control over the AI and the AI taking control over the human?
Crikey. Yeah. Thank you for that. It's a very contentious
just to say issue. That was anonymous, by the way. I don't want to.
So, in 2050, will the deck officer need to learn about call regs? Probably not. The chances are, because we're already developing algorithms for collision avoidance. So, but the system has to be built in a foolproof way. But probably by 2050, you may not see the deck officer actually, in certain cases, not actually stepping in. Our understanding, I'm putting myself out there, I like to be contentious, but by 2050, in some cases, you might not see it. The algorithms can be clever enough to actually not warrant human input.
Okay. Okay. Thank you, Gordon. We're right on time, so I'm going to draw a close there. So thank you very much again.
Thank you.